B is 18, C is 12. That's terrible. A, B, C. Little b is 18. Where does that go? Across from big B. And little c, is that what it said? They do it different in this book. Do you see how I know they do it? I forgot about that. Let's see. Is it in? Well, see, yeah, they said it's 12. So obviously they label it different. I think they give you. Look in your book and see if you can tell me where their A, B's, and C's are, because I forgot about that. Normally C is your hypotenuse, but this book does do things a little bit different. So look in there and see if you can find it. Okay, checking with the book, this is how they labeled it on your homework problem, and it doesn't matter. I mean, if they don't tell you though, if they don't say this side is A, this side is B, this side is C, it's supposed to be the hypotenuse C, the legs are A and B. Yeah, that's fine. So in this one you got B is 18, C is 12, so we're going to take B 18, C 12. That makes more sense, because obviously the hypotenuse is going to be your longest side. And we're looking for all the other missing side lengths and angle measures. Can we use Pythagorean theorem to find A on this one? Yes, because is 12 and 18 rounded answers? No. So we can do A squared plus B squared equals C squared. Somebody want to do that in their head? 18 squared. Good job, Christina. So here we go. A squared plus 144 is 324. Move the 144 over, so minus 144 should give you A squared is 180. So square root both sides. A is going to be, do we have to put plus and minus? No, because you're talking about a side length. So you can dump that. 13.4. Cody did. He was making a guess. So about 13.4. Now, stay away from that. Don't use that to find your other answers, because if you use an answer to find an answer, it's going to be off. So let's look for our angles now. We'll call this theta and alpha, just to get you used to some symbols. Fishy. Yep. So we've got, if we're looking for theta first, yep, SOHCAHTOA. Looking for theta, we've got 18, we have 12. According to theta, 18 is the hypotenuse, 12 is the adjacent, so you got cosine. Cosine of your angle equals adjacent over hypotenuse. We're looking for an angle, so you do theta equals inverse cosine of 12/18. If you want to type it in as 2/3, that's fine too. We'll give you the same answer. So we'll call it 48 degrees. Because you're looking for an angle, you've got to move the cosine over. So anytime you're looking for an angle, use the inverse. If you want to, you can go through the process again, but these angles, since it's just add up to 180, it's not going to be as much of an error there. You could just say that's going to be 42 degrees. But let's go through the process just to get you some extra practice. Looking for alpha, you've got 12 and 18. According to alpha, 12 is your opposite, 18 is your, so the sine of alpha equals opposite, which is 12, over adjacent, which is 18. Same thing, except for this time you're doing inverse sine of 12/18. What is it? Which rounds to 42 degrees. So alpha, 42 degrees. So there you've solved your triangle. Any questions? Okay, first off, applications. A plane takes off at an angle of 5 degrees. After traveling 1 mile along its flight path, and that's something you need to pay attention to, it's along its flight path, not along the ground. After traveling 1 mile along its flight path, how high in feet is the plane above the ground? 1 mile, that's not in feet. So I would change one or the other. I would change probably miles to feet. You're close. You got two of the numbers right. 5,280 feet. And 5 degrees is not a very big angle. Of course, I mean, I'd hate to be flying on a plane and take off at a 70-degree angle. You know, all of a sudden you just start shooting straight up into the air. Yeah, probably would. So 5 degrees. Your angle of takeoff, this is your plane going up through here. You have a 5-degree takeoff, and it travels for 1 mile along its flight path, along this path, 5,280 feet this way. And we want to know how high off the ground it is. This is easy. It would be 85. Yeah, you don't have to find it in this case, but it would be because we're just looking for how high it is off the ground. SOHCAHTOA, sine, cosine, tangent. We're given the hypotenuse. We're looking for what? Looking for the opposite, right? So we are using sine. Sine of your angle equals opposite over hypotenuse. So x is going to be, you can just type it all into your calculator at once, 5,280 times the sine of 5. Anybody tell me what that is? Using a calculator? Times the sine of 5, 460.18 feet. Yeah. 5,280, that'd be like a 1/12 of a mile. No. But it's only traveled 1 mile. For an airplane, that's not very far. Yeah. That's true. That'd be a good problem. Will we clear this building? I bet that's pretty close. 5 degrees, that's probably pretty close. Here we go. Example 5 says a 24-foot ladder positioned against a wall forms a 75-degree angle with the ground. That's easy to draw. This to me sounds like a calculus type problem. You've got a ladder propped up against the wall, except for in calculus it's going to say that ladder is sliding down the wall. The ladder's against the walls. Yeah, it'll say the ladder is sliding down the wall at a certain rate. It's sliding out from the wall at a certain rate. What rate is it sliding down the wall and all this? At what rate is y changing with respect to x and all this? That's good stuff. Shadows. Lots of triangles. 24-foot ladder. So the ladder's 24 foot. Does everybody understand why that would be the hypotenuse? Because that's the length of the ladder. That's not the height up the wall. It says, how far up the wall does the ladder reach? We'll call that my y. Any question on y? I would call it my y. Sine, cosine, tangent, which would you use? Because opposite hypotenuse is sine of 75 degrees equals opposite over hypotenuse, so y equals 24 times sine of 75. It's pretty easy. So what would y be? Should be less than 24. 23.18. Because this is such a big angle. If this angle was 0, how far up the wall would it be? Or no, excuse me, if this angle was 90, how far up the wall would it be? 24 feet. That means it would be pressed flat against the wall. If this angle was 0, how far up the wall would it be? It'd be 0. It'd be laying down. Makes sense. So 23.18 is nearly against the wall. The next part of the problem, I think, asks, how far out is the ladder? So looking for x now, sine, cosine, or tangent. Don't use this. You're given x and 24, that is your adjacent and hypotenuse, so you're going to use cosine. Yes, you could use sine and 15 up here. Yeah, I was going to say that actually a while ago. You can use either one. It's going to come out the same answer. Cosine of 75 is adjacent over hypotenuse, so you got, that's it. 24 times cosine of 75 degrees. So how far out is it? 6.2 feet. How could you check your answers? You got 6.2, 23.18, 24, Pythagorean theorem. If you want to check it to make sure that you are pretty close, 6.2 squared plus 23.18 squared should equal somewhere really close to 24 squared. Will it be exact? No. because both of these are rounded answers. Last problem. We're going to talk about angle of